Good evening, this is Tony Peters with another quick update for you. What I want to do is just talk about these two subsystems real quick in an update. I'll get to where I'm at right now with the artificial sun module and the photocurrent measurement subsystem. Those are two subsystems I'm going to work on later. I am making strides with those, but today I just want to focus on these two individual things that I'm doing right now because I think it's a good baseline to be at, because going into the end of this semester, what I essentially want to do is have a temperature, humidity, regulated box that I can monitor and control with very specific conditions. The ECMS, the Environmental Control and Monitoring Subsystem, is complete right now. It's in prototype phase. I have some pictures that show a little bit more fine detail, but I have a printed wiring board that essentially I bought, and I white wired to specifications, everything from the pull-up resistor needed for the LCD component to the potentiometer adjust brightness, etc. Things like that, going all the way into my digital and analog pins, into the Metro 328. I'm going to put this, encapsulate it into a nice little configuration, and I've got a lot of harness work that I did, a lot, hours worth of it. So this way I can be able to take my DHT22 or my BMP280, and if they go bad, or if I just want to switch them around and move them around in different conditions, or if my cords aren't long enough or whatever, what I'll be able to do is use some of these quick disconnects to unplug them and then put them in a different part of the system. Everything is still working right now, but this is essentially where I'm at with this design. The beta angle subsystem, now that's a little bit different. I've got some things going on with that right now. Namely, as you can see, I have this whole PWB built up to spec for the ECMS. And I did that for a very specific reason, because I wanted something that got eliminated a lot of the other wiring, and that I was able to use essentially two buses I was able to put in here. So I have my mainstay bus that is responsible for my LCD, the input that's going into there for my digital conversions, and then I have my serial relay driver bus, which is on the bottom part of it and on the back side, that allows me to use different voltages. So I'm keeping them independent. And that actually aids me in being able to troubleshoot later on if I need to. Now, moving forward onto the BAPCS, the Beta Angle Position and Control subsystem, there's some changes here from last time that you can see. And the big one is this LCD shield, which is different than the one that I built to spec for myself. And essentially what I'm using it for is to free up some of the digital pins that I may need for later on. And really, I take all these wires and consolidate it down to just the four. The bad side is that this potentiometer here in the back is with a quick screwdriver, is this essentially right here. You can't adjust the display brightness externally. You kind of have to crack it open or just kick it all the way to the full power to keep the LCD as bright as possible. So what I'd probably do is go all the way and then give it a crack out just to be bright enough for what you would need. So you can use your clock and data, and essentially they go to your analog, two different analogs for your input, which does save up a lot of space when you're putting this whole thing together, especially when you're going from the experimental stage to the prototyping stage. So a lot of things are carrying over. I have my manual mode and my zeroize button that I have here, my push buttons. The MG90S is what I'm still using. However, I ran into some other problems with jittering and really just imprecise position measurements. I was using the stepper motor, the 28 BYJ48. It's a 5-volt DC stepper motor in conjunction with the 003 stepper driver board. However, the stepper driver board is not exactly what you would call a precision driver because there's a couple different problems with it. One is that the PWB or the PCB that was built up for it uses through-hole technology and surface mount, which is great, but in this case, the lead protrusion is actually problematic when they went and did their soldering. So they push it through with their surface mount tech, and then they go boop, 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 and then solder everything in here. However, there's a lot of bleed over, and the leads actually got bent in manufacturing, I assume, when they did all this, and then it causes a short. So you're getting erroneous measurements, and you're getting a lot of jitter, and you're like, what the heck is going on? Or sometimes it wouldn't even move. I had actually ordered 2 or 3 other ones, and it's just not working. So I went and ordered a NEMA 17, and it's a very robust American-made stepper motor. And what I needed to do in order to use it was, it comes with other kind of driver boards, but I didn't want to use those anymore because it's just not going to work. So I decided to make my own. So this is actually a shield co-located with some stepper motor functionality. I can actually use 2 steppers or 4 DC motors on here. I put everything together here. It actually came with a lot of the stuff I already needed on it, but I can actually use quite a bit on here. 3 amps max for the steppers, which the NEMA 17 is well below that. But essentially, I'm going to be using this, and it actually goes right on top, kind of like my SD card shield. It just clicks right up on top. All the pins you make line up with all your digital and analog and your main bus pins here. So it makes it a lot easier to work with in the prototyping and going backwards to the experimental phase. So stand by for some updates on those. I'm trying to clean it up from the experimental stage going to the prototype for the BAPCS right now. But as always, feel free to send me an email if you have any questions. My future plans right now, like I said, are focusing on these 2 subsystems. So by the end of the semester, I have a good baseline for being able to see what my environmental conditions are and being able to maneuver an apparatus throughout a simulated solar day, exposing a PV device to multiple wavelengths of light that I can actually quantify. But stay tuned for some more updates on the ASM and the PCMS at one point.